Hi, my name is Esteban Perez de la Vega. I'm with my partners Gerardo Rodriguez Garcia and Patricio Mendez Ursua. We are going to talk about our project about Hooke's Law application. We are going to explain our prototype and also how it works. And we're going to talk about the process and the results we got. Firstly, we have to explain what is Hooke's Law. Hooke's Law is a principle of physics that explains how the elastic materials behave when a force is applied to them. It states that the force needed to stretch or compress a spring is directly proportional to how far it stretched or compressed it. Well, the equation is F, force applied in newtons, equals to K. K is the spring constant, a measure of stiffness in newtons over meters, times X, displacement from the original position in meters.
Our device was a scale, and a spring scale, and the main task was to measure weights accurately. But you may ask, what kind of physics were involved? Well, there was the second law of Newton, the Hooke's law, the equilibrium, and obviously the kinetic and potential energy. But the device completed the task that the homework asked? Well, not entirely, because there was some energy loss. Maybe it was because friction or the spring fatigue or even a human error, but the results wasn't expected and the calculations were wrong. In phase 1 and 2, we did some measurements. For example, the spring, we had to calculate the displacement of the spring. Also the mass helped us to calculate how much force we were applied to the spring. And then we use a program to calculate the force versus the displacement, and the slope gave us the spring constant. But you may ask, what tools we used? Well, we used a ruler to calculate, to see what displacement it was from the spring. Also, we used different weights with different objects with different weights, and the weights we also obviously we knew the weights of these objects. And also we used graphic tools. Well, all this confirmed the linear relationship between predicted by Hooke's law, and this helped us to to calibrate our prototype.
Now, here's our Hooke's Law project from the second partial. What we did is that we had this rope. If we put an object, depending in the height of the object, our rope is gonna stretch. So, with a ruler, we measure that stretchment that the rope do, and we can calculate how much is the displacement of this rope and how much the weight of our object that we put is going to change that measurement. This project relates to real-world engineering in many ways. For example, in the mechanical engineer, uses Hooke's law to design suspension systems, scales, and safety equipment. We can see this in cars. Civil engineer uses this for the understand of the structures and how they deform under stress. Aerospace and automotive fields rely on spring behavior in landing gear and shock absorbers. Lessons learned: the importance of accurate measurement and calibration, understanding material limits, elastic versus plastic behavior, the iterative nature of design and testing, trial, error, and refinement. Some weaknesses that we found were inaccurate or unstable support from the spring, which affected measurements. Also, the spring began to behave plastically after too much force, meaning it no longer obeyed Hooke's law. Difficulty measuring small displacements accurately. Improvements we suggest: use a more rigid mounting system, calibrate the spring to avoid exceeding its elastic limit, and add a digital measuring device or ruler for better precision.
To conclude, this project helps us to apply theoretical knowledge to a real prototype, reinforcing the concept of Hooke's law and teaching us how physics principles are used in engineering tasks to solve real problems. Well, I like this project, so thank you.